All right, sixth grade, last section in chapter 11, talking about real numbers before, okay? Real numbers. And so we're going to start off with a definition. Let me change colors. Real numbers. What are real numbers? Well, real numbers is the set of numbers that includes all rational and irrational numbers. And we have talked about those before, but just to review, okay, rational numbers include all of the whole numbers, and fractions. Okay, they also include, not they also include, irrational numbers are non-repeating, non-terminating decimals like pi, or the square root of something that is not a perfect square, like the square root of 5, and a decimal that just goes on forever and doesn't have any sort of a pattern, okay? The symbol that we use for real numbers looks just like a capital R, but it has almost like kind of like a rectangle for that line on the R. So that is the symbol for real numbers. So what I want to show you here is here we have this big box that says real numbers. So everything that is inside that big box of real numbers are the subsets or subcategories of real numbers. So rational numbers, integers, whole numbers, natural numbers, and I don't know why it's not labeled, but the irrational numbers are out here, okay? Irrational numbers, okay? So example number 1 says place each number at the appropriate place on the diagram given. So we want to be most specific as possible with these numbers. So -3 2/3. What is that? Is that a rational number, an irrational number, an integer, a whole number, or a natural number? Now, what you want to remember is that 2/3 is a repeating decimal, okay? 2/3 is a fraction. It turns into a repeating decimal. So that makes it a rational fraction, okay? So -3 2/3 would be a rational number. It is not an integer because it has a fractional component, okay? How about the next one? The square root of 13, okay? Square root of 13, not a perfect square. So it goes out here in our irrational numbers. Next, okay, I'm just going to cross these off as we do them. Next, we have 7.9, okay? That's a decimal. It's not going off in some, like it's not forever going on, okay? It terminates, it ends, so it is rational. So there's 7.9. Next, we have 4. Most specific category we can put 4 in is natural. Remember, natural are our counting numbers. So we start with 1, 1, 2, 3, 4, and so on. So 4 is a natural number. Then we have 3/5. 3/5 is a ratio. It's a fraction. It ends up being a terminating decimal when we divide 3 by 5. So 3/5 is rational. -14. -14, most specific category we can put -14 in is our integers. Okay, remember whole numbers are always positive, okay, and 0. They are our counting numbers, positive and 0. Integers include whole numbers and their opposites. So integers, -14. 0, most specific place we can put that is in our whole numbers. -2 times the square root of 5. The square root of 5 is not a perfect square. So that is going to be, that should be a -2. -2 times the square root of 5, that's going to be irrational. -8 is an integer. And 291, most specific place we can put that is natural numbers. It is a counting number. Okay? That's how we work through something like that. Skill check number 1, working through the exact same thing. Negative 0.5, okay, that is a terminating decimal, therefore it is rational, okay? Number 2, 5 and 6/15ths, okay, 5 and 6/15ths, that also is a rational number. Okay, negative square root of 15, that is not a perfect square. That's going to be irrational. It's going out here. 0 is a whole number, and 16 is a natural number. That's how we qualify and or classify our numbers, okay? Now we're going to review some properties of addition and multiplication that we have talked about already this year. So I'm not going to spend a lot of time on them. Properties of addition, commutative. Remember, we can change the order of the addends, okay? We can commute them, we can move them around. Associative means that we can change how we group the addends when we are adding. And the identity property of addition means that no matter what we add to 0, the number does not change. So a plus 0 is always a, 0 plus a is always a, okay? Properties of multiplication that we have also talked about already this year. We have the commutative, which is just like the addition, okay? We can change the order of the factors. Associative, we can change the grouping of factors in a multiplication problem. The identity property is similar in multiplication to addition, except for the fact that that instead of addition, when we are adding something to 0, and that does not change the number, in multiplication, when we multiply a number by 1, it does not change the number, doesn't change the number, okay? And then we also have a 0 property of multiplication. Don't get that confused with the identity property of addition that uses a 0. But the 0 property of multiplication means that no matter what we multiply by 0, the product is 0, okay? Example number 2. Sorry, I need to turn my page in my textbook. Example number 2 says fill in the blanks and name the property. So 7 times 25 is equal to what times 7? Well, that's equal to 25 times 7. And what property does that illustrate? Well, we changed the order of the factors. So that would be the commutative property of multiplication. This is a sufficient abbreviation for commutative property of multiplication. If you just write commutative, you will be marked wrong because there is a commutative property of addition as well as one of multiplication. I don't know which one you mean if you just write commutative, so you have to indicate multiplication or addition. This is an appropriate abbreviation, okay? 0 plus 19. 0 plus 19 equals what? Well, it equals 19. This is an example of what property? The identity property of addition, because that is, no matter what we add to 0, we get the original number that we started with, okay? Now, a couple other properties, okay, that we will be moving through and using a little bit through the rest of this year and then a lot in pre-algebra and algebra, okay? The first one is the distributive property, and that means if I am multiplying A times the sum of two addends, so A times the sum of B plus C, that is the same as multiplying A times B and adding that to A times C. And I like to indicate that like this. We take that number that's on the outside of the parentheses and we multiply it by both the first addend and the second addend, and we add them together. So the product of a factor and a sum is the sum of the products of the factor with each term of the sum. So here we have -3 times the sum of 5 plus 8. That is the same as -3 times 5 plus the sum of -3 times 8. Order of operations would be very, very important here, okay? Over here, we have -3 times 13 because we do what's in the parentheses first. 5 plus 8 is 13, okay? And on the right-hand side, we do what's in the parentheses before we do any addition. So negative 3 times 5 is negative 15 right here, plus negative 3 times 8 is negative 24. Okay, on the left-hand side, we have negative 3 times 13, that is negative 39. On the right-hand side, we now have negative 15 plus negative 24, which is negative 39, just showing us how the distributive property works out. Another property we have is one called the inverse property of addition, where a plus negative a. So a number plus its opposite is always equal to 0. Okay, always equal to 0. And you could write that a plus negative a or negative a plus a. So the sum of a number and its opposite is always 0. 3 plus negative 3 is equal to 0. 6 plus negative 6 is equal to 0. Negative 21 plus 21 is equal to 0, and so on and so forth. Lastly, we have an inverse property of multiplication. And that means a number times its reciprocal is equal to 1. Okay, is equal to 1. So over here, we have 5 times 1 over 5 is equal to 1. 3 over 7 times 7 over 3 is equal to 1. So a number times its reciprocal is 1. Why is the reciprocal of 5 1/5? Because you need to remember we can always write our whole numbers as a fraction over 1. So the reciprocal of 5 over 1 is 1 over 5, and the product of that is always going to be 1. Okay? To make sure we understand additive and multiplicative inverses. Okay? Additive inverses are two numbers whose sum, that's addition, is 0. Okay, is 0. And that is the identity. 0 is the identity for addition, where a plus negative a is always equal to 0. A and negative a are what we call additive inverses because their sum is always 0. Multiplicative inverses are two numbers whose product, because we're talking about multiplication, is 1. And 1 is the identity for multiplication. So a times 1 over a is equal to 1. A and 1 over a are what we call multiplicative. And it took me a lot of practice to be able to say that word. Multiplicative inverses. Okay? Example number 3 says fill in the box. Okay? 29 times 1 over what is going to be equal to 1? Well, this is an example of an identity property, okay? Multiplicative identity. So 29 times 1 over 29. 29 times its reciprocal will give us 1, and that is an example of the inverse property of multiplication, and you have to make sure you indicate that. Box skill check number 3, 1 is equal to 1 over the square root of 3 times what? Times the square root of 3. Those are multiplicative inverses of one another. This is an example of the inverse, and I can write inverse like that, inv property of multiplication. Okay? 3/5 plus blank is going to equal 0. 3/5 plus its additive inverse, negative 3/5 is going to equal 0, and that would be an example of the inverse property of addition. And that is the end of chapter 11.